This is Natural Selection Lesson 1.5, Activity 2. So newts aren't the only species that show variation in traits. We're going to look at an example of another population with different traits for the same feature. So these images show a type of moth called a peppered moth. Some moths in this population are entirely dark, while others are white with black spots. Both the left image and the right image have two moths in them. Can you see the moth in each image? So depending on the color of the environment, some peppered moths are camouflaged and can blend into their environments. So the question is blending in with the environment always helpful for survival? So we're going to investigate this question in the sim. We are going to be looking at the australopes. And you're going to observe australopes in a yellow environment. So if blending in with the environment is always adaptive, we would expect that being yellow, that the australopes being yellow, would help them blend into their environment, and that their body color trait would be yellow and it would be an adaptive trait. So the question is, or the claim, is yellow color is always an adaptive trait in a yellow environment. So you may be wondering, well, what does adaptive mean? We've been hearing it, but sometimes we got to go back to the glossary and check the definition. So an adaptive trait is a trait that makes it more likely that an individual will survive in a specific environment. So when we're talking about yellow color always being adaptive in a yellow environment, we are wondering if yellow will help that organism survive, or in this case, the australope survive in a yellow environment. So what you're going to do is you are going to pause the video and go to Activity 2 and select whether you agree or disagree with this claim. So go to Lesson 1.5, Activity 2, and do page 1, and then come back to the video. So pause the video, go to Activity 2, Lesson 1.5, do page 1, and then pause the video. All right, now that you've done page 1, we're going to go on to page 2. So you are going to observe australopes in two different environments in the sim in order to collect evidence for or against the claim that you just selected in page 1. So in this sim, you are going to be changing. So first of all, you're going to be selecting camouflage. So when you go to Activity 2, you have to change it to camouflage. And when you do this, you can see that, so on this page it says camouflage, and then under biotic factors, make sure include Carnithons is selected. So first thing you'll do is you're going to change this to yellow, and then you're going to make sure that Carnithons are included. So that's how you do this one. So I kind of did it out of order, but so under biotic factors, include Carnithons. We have included Carnithons. Under abiotic, it says change surface slider to 7. So, and then you're going to run for 50 generations. So like we've done before, we'll press next, and I change the two things at once. I run it, I'll speed it up to 4, and then wait till it gets to 50. All right. And again, you can watch what's happening here. This is a real live histogram of how it's changing, if it's changing. So then once you get to 50, you're going to press analyze and then answer these questions. So you might see stuff that says like my partner. You don't have a partner. So just ignore that and just do it. You're just going to do it for yourself. So then once you get done with that, you're going to go to page 3, and this time you're just basically doing the exact same thing, but you're not including Carnithons. So once you get this to 50, and once it goes up to, once you answer the questions on page 2, you're just going to move on to page 3, and then you're going to keep the yellow surface, you're going to change it to 7, but you're not going to include the Carnithons this time. Run it for 50 generations, and then analyze what happens. So what I want you to do is you'll pause this video, you'll go to page 2 and you'll complete the sim activity for page 2, then you'll go to page 3 and you'll complete the sim activity for page 3, and then you're going to come back and play the video. So one more time, pause the video, lesson 1.5, activity 2, complete the sim activity on page 2, and then go to page 3 and complete the sim activity. When you finish with the questions for page 2 and 3, come back and press play on the video. So, what we should have seen now that you've completed page 2 and page 3 is that in environment A, when we include the Carnithons, which is this environment, the distributions of traits in the population changes from blue, green, and yellow australopes to entirely yellow. So in a yellow environment, when there are Carnithons, which will eat the australopes, the yellow australopes become more common, and the blue and green australopes are most likely to be eaten by the Carnithons. So I'm going to pause this just a little earlier than 50, but you can see that we started off with a lot of different traits here. So the variation of traits is large. But then over time, we change the color. You can see that the trait of 7, which is the color we set it at, becomes the most common colored australope. So the blue and the green ones are no longer existing anymore. They're most likely to be eaten. So if I come back here and I set this again to the don't include them, and then I run it in the 4. So this would have been, it goes fast if I leave it on this page, but then if I go off, it goes away. But so this would have been page 3. So if page 3 was sliding it to 7, which is on, and then do not include the Carnithons, and so that's what I've done here. And so what you're going to see happen is, if you look at these, over the course of the 50 generations, the distribution of traits in the population changed very little. So the yellow australopes do not become more common, and all the australopes are equally likely to survive. So I'm going to pause it again a little earlier than 50, and you can see that it's not really changing very much. You know, there's a little bit of up and down, but the yellow is not any more likely to survive. They're all about equal likely to survive. So when predators are present in the environment, which is this page 2, when predators are present in the environment, the yellow australopes were more likely to survive because they blended in with their environment. This makes sense. If you're yellow and you're in a yellow environment and there's things there that can eat you and you are camouflaged in, you are more likely to survive if you are camouflaged. So the yellow color was an adaptive trait in this scenario with the presence of the Carnothons. Remember, adaptive trait is giving you, let's just take a look again. I want to use the exact words. A trait that makes it more likely that an individual will survive in a specific environment. So a yellow ostralope in a yellow environment is an adaptive trait because it will make it more likely that that ostralope will survive in that environment. So when yellow color was an adaptive trait, the ostralopes with the yellow color became more common because they're more likely to survive. They became more common. So when the predators were not present, which was page 3. So on page 3, when we did not include the Carnothons, the yellow ostralopes were not more likely to survive than the green or blue. All the color traits were equally adaptive in this environment. The yellow ostralopes did not become more common in the population. The yellow ostralopes only become more common when being yellow is adaptive. So whether or not traits are adaptive depends on the conditions in the environment. So we did the same thing. We had yellow 7 yellow ostralopes. The yellow were only more likely to survive in the presence of the Carnothons. It was only adaptive when there was Carnothons. It was not adaptive. Yellow ostralopes were not more likely to survive when there was no Carnothons. So the different traits are adaptive or non-adaptive in different environments. So if we go back to our claim, here, yellow color is always an adaptive trait in a yellow environment. Well, in one scenario, the yellow color was adaptive when the Carnothons were there. But in the other scenario, the yellow color was not adaptive in the same yellow environment without the Carnothons. So our evidence would refute this claim. It would say that this claim is not true. So we have some key concepts. And I need to get to the right page. So, over many generations, individuals with adaptive traits become more common in a population, while individuals with non-adaptive traits become less common. So this came from lesson 1.4. So what we just saw is that when yellow color was adaptive, the individuals with that trait were more likely to survive and became more common in the population over time. So yellow ostralope in a yellow environment with Carnothons, they became more common in that population. Traits that were non-adaptive became less common, like the blue or the green color, because they did not survive in that yellow environment with the presence of Carnothons, and they went away. They did not survive. So the next key concept is that whether or not a trait is adaptive depends on the environment. So yellow fur was only adaptive in the yellow environment with the predator. In the absence of a predator, the blending into the environment did not help the individual survive. So this would be similar to if you want to connect it back to the pepper and moss, you'd have to think about when these would survive, be more likely to survive or less likely to survive. So I'll let you think about that now. That's the end of the video. Make sure you go press hand in Amplify so that you can get your points for those 3 pages.